So thanks everyone for joining us today. Um, if you are listening in live, I'd appreciate it if you could put yourselves on mute. Um, this is going to be recorded and it will be available on the Digital Infra Network after today's session. So if you could mute yourselves. And again, I'm hoping, Simon's joined us. Great, so Simon is on the call as well. So initially I'm going to hand over to Carsten, but before I do, I'm just going to give you a bit of an introduction. So Digital Infra Network, we're focused on the journey that digital infrastructure is taking towards decarbonizing, for want of a better description, and how data centers and related assets can be more sustainable. And that's everything from the application layer all the way down to the grid, including the data centers. We cover everything from power consumption and all other aspects of the industry. We've got around about 10,000 loyal followers on a monthly basis on our online site, and we're just starting to do some more live events around this subject. And the precept behind the platform is that digital infrastructure is going to and is making a material impact in towards sustainability and helping towards climate change mitigation in multiple ways. But in order to do that, it needs to be sustainable. So we are joined today by a couple of specialists, and we're going to be covering a subject which I think will become more and more important as we move forward. It's the relationship between data centers and the grid, partners in crime or a holistic solution. And we've been talking about this for some time. And we've got two very good people on the panel. We've got Carsten Bowman, who's the Director of Strategic Initiatives and Solution Architect for Schneider Electric, and has got some good insight into the companies that they're working with and off-takers and integration that they're doing from an energy generation perspective with grid assets, I'm assuming in various different locations. And then we've got Simon McCormack, who's the CTO for Echelon Data Centers, which are a large European hyperscale data center operator, and they are building a significant number of assets around Europe and are very involved in supplying capacity to the grid as well. So I think this is going to be a really good conversation. So I'm going to hand over to Carsten. Again, if you're joining us now, if you could please make sure you stay on mute. I'll come back in about 10 minutes after Carsten's finished. We then have Simon on the Simon's presentation, and then we'll have a panel at the end. If you've got any questions, please put them in the group chat, and we can make sure that we answer them at the end of the session. And thank you very much for joining us today. So go ahead, Carsten.
Yeah, thank you so much, Dan. Hello, everyone. Really, it's great to be back with you guys. And so I want to spend the next 10 minutes and invite you a little bit on a journey in terms of like the data centers and the grids, excuse me, and how they interact with each other. And as we go through this journey, I want to start with what you see on the slide here right now. So we see four vectors, in the data center industry that are actually posing significant challenges in developing more capacity as the world is becoming more digitized, and everything is relying on digital services, so therefore data center capacity just continues to grow. And so we see these four vectors, which number one is a power quality challenge, a quantity, like how much power is actually available, and then of course sustainability, and we also see a cost challenge. So these are the four key drivers, when we look at how data centers are interacting with the grid and how how we need to solve against this or for that. So, and I want to set the stage just briefly here. So the grid as it is, and this is not only necessarily true for the United States, but perhaps in other regions around the world as well, the reliability is not getting better. And the data you see here right now is from the United States. So on the left-hand side, you see the amount of outages that happened over the last 2 decades, from 2002 to 2020, almost 2 decades. And you see there's clearly a trend line so that the outages becoming more frequent. And the majority of them actually here in the United States are weather and natural disaster related. And then there's some others, system operation challenges and so forth. And then, by the way, this does not even include the big freeze we had in Texas in 2021. So that's just even, contributing more to it. And but there's a clear trend line that the reliability is not as we all wish it would be. And the data center industry is very well aware of that. And that's why we, plan in our infrastructure for resiliency, and we have diesel backup generators and all these kind of elements. And that's all great. At the same time, they are posing as well certain constraints. On the right-hand side, you just see another picture basically telling the same story. This is a snapshot of 2020, and you see the outages. So on the right-hand side, you see it's basically telling the same story. And so the size of the bubbles is basically the amount of outages, and then the shades of gray, the darker it is, it's the duration. And so there you see, unless you're in Montana, where we don't necessarily see a lot of data center infrastructure, but California, Texas, Virginia, big markets. So there's certainly kind of challenges we have, and that's just about the quality. Now let's talk about the quantity I mentioned earlier, the challenges we have. So by 2050, that's about 27 years away from now. Still, yes, it's a long time, but there will be a significant power generation deficit. On the left-hand side, you see the demand we're currently having is about around 40,000 terawatt hours. And you see the demand and then everything that came offline, oil, coal, and gas, and then what came online, nuclear, hydro, wind, and solar. And that makes out about 40,000 terawatt hours. And at the same time, as everything gets electrified, transportation, heating, industry processes, data centers, of course, you're consuming around, somewhere around 2% of all the energy right now globally. So we will see there is a demand for over 100,000 terawatts, and that leaves us with a gap of 68,000 terawatt hours. And then the big question, of course, is where is this all coming from? So there's a massive amount of load, and there's not going to be a matching generation asset from the utility companies. So if we build more data centers, we have to ask, so how do we get the power? And that's one of the challenges we already see right now in different geographical regions in the United States, also in Europe, where we simply don't have enough power. And as much as we want to build, we can't do it. So when we look at the next slide, so here's just a point of reference. You will see that the data centers, which consume around 2% of the global energy, some say it's 1.5, some people say it's 3%, somewhere around 2%, depending on what kind of research data we believe. But it's a significant amount of energy. And as you can see, all the data centers combined, they consume more energy than some of the countries, right? Like Egypt, South Africa, and others. So therefore, it's an enormous amount of electricity required. And then specifically to the locations in the United States, you see on the right-hand side, the top 10 locations in terms of capacity. Northern Virginia, by far the largest with, 2.6 gigawatts of capacity, followed by Dallas and Northern California and the Silicon Valley area, and then other markets around in the United States. And of course, we also see significant growth in Europe and in others, and that's what we will see here on the next slide. In the next 5 years, we will see, and Echelon is talking about it in terms of their build-out capacity in Europe, but we will see there will be another 39 gigawatt of capacity, data center capacity, coming online within the next 5 years. And that's about 23 million households worth of electricity. That's about 360 times as many or as much as the existing large data centers we have around the world right now. So now thinking about the quality of power challenges we have and thinking about the capacity challenges, we have to really solve for those challenges differently. And this is where we have to work together with the grid and the utility companies. And one of the things we see as the future progresses, what the data center of the future needs to look like, it will be a data center that will be closely interconnect with the grid and becoming a good neighborhood steward. That means not only an off-taker of large amounts of energy or electricity in this case, but also being able to support the grid in times of needs. Because as we build for resiliency in the data center, we have what we would now call stranded assets, which are typically our diesel backup generators. And their sole purpose is an insurance policy as to when something happens to the utility or grid, we are firing up our generators and then we self-generate the power. Now, these diesel generators, as wonderful as they are, they're not necessarily the most sustainable assets unless we use HVO and certain kind of other means in terms of like utilizing those diesel generation assets. But so therefore we see that in these conversations we have with our customers, there is a greater shift towards a more sustainable operation. So therefore we are becoming also good stewards about our planet itself, and we are contributing to the reduction of greenhouse gas emissions, being emitted, and therefore for global warming. Data centers, they need to continue, although we've done a tremendous job in the industry over the last decade in terms of becoming more efficient, and we measure this in PUE, but we want to continue to drive efficiency for cost, speed, and space as well, the amount of land we're using, and then the capital we need to deploy to do that. Resiliency is always a big challenge, for the data centers. So we can't become more sustainable and become less resilient. So therefore, there's some mandatory requirements for us in order to avoid any kind of unplanned downtime, as we saw earlier in the slides about the power quality coming from the utility company. But then we also see two more vectors. One is the becoming more adaptive, because there's a lot of new technology becoming online, whether these are battery chemical compositions of different battery technology, whether these are, let's say, fuel cells, and this could be hydrogen fuel cells or PEM fuel cells, whether these are natural gas generation or CHP at certain areas. So we see there is the need for integrating technology in a more flexible way and more adaptive. So therefore, we're increasing the return on capital investment for allowing our data center operation to work today, but also leveraging new and nascent technologies to be integrated without throwing the baby out with the bathwater. And then therefore, we're becoming flexible. And then the last one is the grid interaction. So what we see now, we are able to not only take the energy, but we can also kind of export it. And then I'm just going to go right through here very quickly. So we see the future of a data center where the words of gensets and UPS and microgrids, they are not distinct, but they actually all come together and converge, and create this kind of net zero application and being a good steward. And here you see a slide, very kind of high level, cartoonish like. On the left-hand side, we see the traditional data center design. The energy flows in these green arrows just downstream, from the utility, and then we have a backup generator in case something happens, and then we support the load. On the other hand, on the right-hand side, we see more a dynamic, adaptive kind of system where energy can now flow bidirectionally. So we can not only shut off energy, but we can only export energy back into the grid. We have different sources, and specifically renewable sources. And then we may have different loads. Not everything has the same criticality. And it could be AC and DC loads or any combination of that, in the same way as in generation assets. Not every generation asset is natively AC, but a lot of DC is available. So when you think about battery, when you think about fuel cells, and other kind of technologies, they are natively available in DC, and they can be more adaptively and more flexibly integrated. And here's just a view as to how that could look like, in terms of like, it's a combination of gensets, batteries, fuel cells, flow batteries, renewables, other assets, and then we may have AC and DC loads. And so one of the things I want to mention here, in the traditional design, it's black and white. We take everything from the utility, or we run everything on the generator. While in a more flexible system where we interact with the grid, it can actually vary. We can make up the load we need from different energy generation sources, some of the utility, some on-site, green, renewable, a mix of those. And that's really the challenge and the opportunity we have in order to make this happen. So the key takeaways, Sustainable on-site power generation and consumption allows supporting and being a good community neighbor. So it's not just like the big energy hawk, which takes up all the energy, and therefore, so there are concerns in the community. And then when we look at the distributed energy resources, the perfect mix, depends on different geographical and regional constraints. Battery energy storage system is not a panacea to solve all the problems. So we encourage our customers and we work with them to do some feasibility studies specific to locations as to what is the most sustainable, most affordable, and most resilient and reliable kind of operation. And then we need to look at an adaptive infrastructure that improves our return on capital investment in order to not have those stranded assets, but to actually use them to pay for it and help us in our financial balance sheet. So that's my part. I think it was just a little bit over 10 minutes. And contact information, you see it here, and then we can go from there. Right, back to you, Dan.
Yeah, that's great, Carsten. If you could disappear and stop sharing your screen, please.
Sure.
I've got a few questions for you, but we'll ask them at the end. And then Simon McCormack, if you could join me on screen, I'd appreciate it, and then we can move on to the next part of today's session.
Yep, just struggling to unmute myself. I am ready to go.
Cool. Have you got? Are you real? Have you got a picture as well?
I am indeed. Oh, sorry. Yeah, I forgot to click that button, didn't I? There we go.
Cool. So listen, hi Simon. How are you, sir? You well?
Yeah, I'm good. I'm good.
Good. Cool. So just by way of intro to everyone listening and those that are going to listen to this afterwards. So Echelon, as I mentioned at the beginning, are a data center developer based in Europe. We've worked quite closely with them for some time now, and I think all data center operators in Europe have been struggling with getting available power from the grid, right? For the development assets, and Echelon are one of the first that we've seen that have taken a slightly different approach to this. So hopefully Simon's going to share that with us today, and then we can cover off any questions after this session. So I'll hand over to you, Simon. You should be able to share your screen at the bottom, and then I'll come back when you're finished and we can deal with some questions. Okay?
Yeah, thanks very much, Dan, and thanks everyone for joining in and giving me the opportunity to talk about what Echelon is doing today. So the title I've got for this is in Power in the Future, the confluence of power generation, renewable energy, and data centers. And it's for us, it's as simple as that. It's bringing together those three elements, so that we have an empowered future, but also a sustainable future, which I'm gonna talk about quite a bit. Just as a quick intro, though, Echelon, we're an international infrastructure developer, but our focus is on providing the large-scale assets that support the growing demand for data and compute capacity in the global economy. We're not let's say a retail co-location provider. We're not at the sort of 2 to 5 megawatts end of things. We're more up at the hyperscale end of things. So what I've got on the screen there is a couple of snapshots of projects that are live for us at the moment. We've got our facility in West Dublin, which we refer to as Dub 10, and that's 3 30 megawatt facilities plus an 18 megawatt building. The first 2 30 megawatt buildings that you see on screen there, they have been leased to TikTok, and this is part of their move into Europe, and they're going to have their first handover at the end of the year. The image you see on the right, that's from our LCY 10 facility, which is located in the Docklands. We've got an 18 megawatt facility there, which is relatively chunky for the area, given how new it is. We've done some of our initial handovers to the customer there. They're up and running, they're live, and we should have the rest of the project finished for the middle of next year. Globally, I suppose our thesis or our philosophy or objective or goal, whichever way you want to put it, is focusing on those large land banks, large scale projects, ability to bring in large quantum of power, renewable power, I should say, and to focus on that end of the market. That's quite important to us for a couple of reasons. One, it's just where we see the efficiencies and being able to make a profit, quite frankly. But it's also to do with the availability of power and the flexibility of it. That sounds kind of counterintuitive, that bigger schemes means more flexibility and more availability. But what I mean by that is that we've got an ability to develop our own generation assets, our own transmission assets, and to deploy the large scale renewables as well. It's tricky. We're getting into a real paradigm shift, we feel, at the moment, in terms of days gone by, it would be you apply to the grid or the local utility for your grid connection, you get it, and you pull power from that, and off you go. Nowadays, we're looking for the quid pro quo from the utility. Build renewables, build other forms of on-site generation, build transmission assets, and then we'll connect you. So when it comes with that quid pro quo, smaller doesn't mean better. We want bigger, and again, we want to get those efficiencies of scale. So I suppose a little bit about myself as well. I focus mainly on Echelon's interactions with its customers, making sure that the product, so to speak, that we develop is suitable for those customers, and that it is suitable for the market, at large. And that flows all the way through then to agreeing technical specs, agreeing commercials, and getting through into an operational space. So in that regard, I work quite closely with our construction teams as well as our operational teams as well. I said a few minutes ago at the beginning that Echelon has a big focus on sustainability. And maybe just to sort of drill down or put a little bit more color on that, what we want to be is a sustainable prosumer of energy. Okay, so not electricity, energy. And by prosumer, we mean we want to be both a producer and a consumer. Okay, and we want to do that encompassing the three pillars that make up sustainability. So that's economic, it's environmental, and it's social. So if I just take each one of those in turn, when we talk about being a sustainable prosumer of energy from an economic perspective, it's about sustaining ourselves, Echelon, as a business now and into the future. If I take a good example of Dublin, which is where I am today, we've had competitors of ours, other developers of data centers, leave the market because they haven't been able to overcome the power issues. We have been able to do that because we have decided to design, build, and operate our own thermal power plants. And I've just put a little snapshot there of one of the Caterpillar gas turbines that we are deploying on site at the moment. So if you were to go to our Dub 10 campus, you'll be able to look around and you'll be able to see a couple of 16 megawatt gas turbines there at the moment. So we've got a sort of day final capacity. When I say day final, that will be a year after next. We'll have a day final capacity of 150 megawatts electrical, which is not a small power plant. We're doing that. We're building it. We're going to operate it, and that's what keeps us in business. It keeps us, allows us to keep developing our mission. It allows us to achieve our mission. And so while at first glance, it might seem that the deployment of a gas turbine or the build out of a gas turbine power plant is the most sustainable thing in the world. We do feel it that way. We are conscious, though, that that's not sustainable forever. It might get us through the short and the medium term, which is why we are also actively in the renewable energy space as well. So at our Dub 20 campus, which is about an hour south of the city centre of Dublin, we've got our we have a joint venture agreement with SSE Renewables to bring in their Arklow wind bank project, which will see about 800 megawatts of wind generation off the east coast of Ireland. So at a time while we are actively deploying a thermal power plant in Dublin because of the constraints there, we are also looking to the future where we are bringing in renewable energy projects, and where that will be used to power the data centers in the medium and the long term. We also see ourselves addressing the social sustainability issue through the deployment of batteries. So again, at our Dub 20 campus, we have a 400 megawatt hour battery compound, battery energy storage solution in development there, which again doesn't sound like the most obvious approach to social sustainability. But how we view it is really as a support to the grid. So by providing the battery storage, we are allowing for periods of low renewable energy on the grid. And I suppose more accurately, we're allowing for that transition between, a period of high renewables to a period of low renewables by doing the bridging and that the grid needs to bring on its thermal assets. So again, what it might seem counterintuitive, the batteries are a big part of how we improve our penetration of renewables into the Irish grid. And I guess that leaves us with the third one of environmental. I sort of spoken about the energy side of things quite a bit there already. So for environmental sustainability, it's about bringing those together, and the picture you actually see there is of our Dub 20 campus. It used to be a manufacturing facility for fertilizer. It had a lot of contamination when we initially bought it. So the rehabilitation, the regeneration of that land with 21st century power assets, with 21st century industry is obviously a huge part of the environmental story there, and a huge part of how we need to look holistically to be sustainable. So with only 10 minutes to talk, I'll really wrap up with some challenges and opportunities that we see, because I suppose what I like about this, apart from the fact that I wrote it, is that we can distill down into a page the challenge that we have today, what Echelon is doing about it, and really the opportunity for the future. So the first one I have there is that the energy system operators, whether that's here, it's in Germany, it's in UK, it's in France, it's wherever, needs a multi-billion euro investment to deliver the infrastructure and to provide those services. We can build the private sector can build as much wind energy, as much solar, as much nuclear as it possibly can. If it can't connect it into a system that delivers that to homes and businesses and industry and manufacturing across the country, then it's really pointless. What we Echelon are doing, and what we would like to do more of, is that we'd like to support that investment by design, building, and operating that infrastructure ourselves. So if we are capable of building a $1 billion data center campus, a $1 billion renewable energy project, there's no reason why we can't build a €1 billion grid system either. It benefits us, it benefits the grid, and it benefits really everyone in the country where we're working. Challenge number 2, achieving decarbonisation targets within the stated timelines. Again, the scale of the assets that we're delivering, the the demand that they create, but also the supply that they create, can really help accelerate those decarbonization targets. We've done a lot of work on this. We've recently had a study completed by Baringa, which shows the decarbonization of the Irish grid, not just the Echelon portfolio, not just an Echelon site, but the decarbonization of the Irish grid from bringing on renewable assets. And we have the capability to do that. So in one single movement, we can change a lot of that. We can change a lot of that momentum. The third challenge is that we need a lot more collaboration. The energy systems, and I'm not just confining it to electricity. I'm also talking about gas. I'm also talking about I should extend it to water as well. Requires a great deal of collaboration. The owners of those assets, they require the private sector to collaborate with them. Again, an upgrade for data centers and for industry is really an upgrade for all. And again, we probably need to look at some sort of shift in terms of how things are done, whether it's public-private partnerships or something like that, to develop them out. So, if I take what we're doing at Dub 20, we've got the renewable energy coming in. We've got it supported by batteries, and we're executing on our business case of building data centers. In Dub 10, it's a similar story. We built the transmission assets that the system operator is going to own and operate. We're connecting in a thermal power plant there. We're taking on that design, build, and operate risk ourselves. And then we're able to attach our data center business and to run that successfully as well. So, we see these challenges. We see the opportunities. We think we're trying to achieve those opportunities. But really, it requires us to be forward thinking. It requires the system operators, governments, regulators to be forward thinking. But the ultimate goal, and this thing I want to leave you with, the ultimate goal is that we can create a future that has better infrastructure, better security of supply, and cheaper supply as well for everyone. So with that, I'll wrap up and say thanks again for listening to me today.
Yeah, thank you very much, Simon. That's really interesting. Carsten, maybe if you could come back and then we could take a few questions. So I'm going to start with you, Simon, if I can, just to clarify a couple of the points that you made. So within the, and I know the answer, but I think it might be better to clarify it a bit in a little bit more detail for the audience. So you're designing, building the transmission assets for your data centers, right? And that includes the amount of power that you're planning on consuming for that data center asset, plus additionality for the grid. And then you're providing that asset back to the utility to then operate. And that's part of your kind of data center model, where you come into a new location, you find a land asset, you add additional power to the grid, you cater for your particular power that you need for your site, plus you add net new renewables or relatively low carbon power to the grid as well. Is that accurate?
Yeah, that's absolutely it. And we've been in that position since the business started in 2017. So while there are plenty of people in here that might take credit for being super forward thinking on this, I think it was a little bit more accident. We initially got told by the grid operator in Ireland, no, you can't have a grid connection there. We said, well, what if we build our own? They sort of shrugged their shoulders and said fine. And that's what we decided to do. That at the time was something everyone else kind of turned their nose up or balked at. But now in Dublin is the only way of securing an actual import connection from the grid.
So when you're talking about the research that you've done in terms of decarbonising the Irish grid, You know, is that something that you're seeing other operators doing now? Are you seeing other kind of energy intensive industries following suit and doing the same thing? And is that part of the decarbonisation strategy for the grid? Or could you tell us a little bit about that?
Sure. So I suppose that at the moment, what we see is the typical scenario is that if you have 1 MWh of demand from your data center, it gets matched with 1 MWh of renewable energy. You know, through a PPA or a guarantee of origin, something like that. What we're saying is we're going to take a step further. We're going to procure additional renewable energy for the grid, so that it actually displaces assets, carbon intensive assets from the grid instead. So just in raw numbers, if we have 100 megawatts of demand at our facility, we're buying a 300 and let's call it 400 megawatt PPA instead, so that excess carbon, sorry, the excess power from the PPA pushes off from the grid, you know, gas or coal or peat burning facilities instead. So we've been able to measure it down to the tens of thousands of tons of CO2 in a 15-year period, how much impact we should have from being connected to the Irish grid, and we're sharing that with our stakeholders.
Okay, cool. I'm going to come back to you, so don't run away anywhere. But so, Carsten, a couple of questions for you. This 5 gigawatts that you reference, where's that number come from, first of all? And, you know, does that include all of the new AI capacity that we're seeing flooding the market at the moment? So that's just an interest thing. And then how are you seeing kind of this kind of new design being incorporated into data centers? Are you seeing data center operators shifting? What percentage of data center operators are you seeing shifting from the off takers to contributors within your business?
Yeah, so I think first of all, you know, the increase of capacity requirements, you know, over the next several years, you know, is coming. I mean, artificial intelligence or generative AI and any of those applications is just one of the you know, energy intense applications that's really shifting the way we look at data center designs, because, you know, there's all of a sudden we see a rack of a single rack with a density of between, you know, 50 and 100 kilowatt per rack. And that's an enormous amount of energy. It's an enormous amount of heat. So we see these kind of AI-enabled zones in data centers being developed right now in order to accommodate for this, rather than sticking one of those NVIDIA H100 multi-cluster, you know, $250,000, $400,000 worth of server in one rack, and then you know, 70% of the rack is still empty. So we're trying to find new ways in terms of like providing the energy and the cooling requirements for these high density applications. So AI is certainly one of them. But then in general, I mean, everything gets digitized right now. You know, I mean, smart industries, smart cities, smart hospitals. I mean, just name it. It was just increasing. Simon was mentioning, and I was chuckling a little bit about this, you know, like TikTok, you know, is one of the providers, you know, or utilizing this data center space. And, you know, we ask ourselves, you know, in terms of resiliency, if we don't have enough data capacity at some point, you know, do we need to watch a TikTok cat video, or is you know, a remote operating, you know, on a patient, you know, more important? And I think it really depends on how you look at it. Either one, you know, we're not here to decide, you know, whether watching a cat video is more important than others. But everything does get digitized. I mean, look at us right now. I mean, you're using a digital platform to have this kind of conversation, and it just keeps on growing. So the demand is growing because of everything is being digitized, and we're living in this digital transformation as we're going right now. And then as part of your second question, how many of those data centers do we see shifting to, and Simon mentioned this prosumer, sometimes, you know, we consume, sometimes we produce, and maybe we can export. There's a different maturity of customers. I think in Europe, we see a higher adoption rate although it's still nascent as well in terms of being able to interact with the grid, right? So for example, in the Nordics, in Europe, we see fast frequency response, very attractive, financially attractive solutions to help stabilizing the grid in terms of frequency and voltages by injecting power back into the grid, and also by very quickly reducing load, on the data center. So therefore, we have to have assets like battery energy storage system or energy storage system attached to UPS, being able to kind of absorb this kind of quick reduction and creating these financial value streams. We see other data centers there, especially in the United States right now, where we're looking at reducing load. So if, for example, in times of need, when, let's say, in the summer in the afternoon, when there's a lot of load requirements, and yet there's not enough generation assets to actually more frequently and more automated participate in load reduction programs, and utilities incentivize our customers. So we see we're early on in this kind of journey. Some data center operators are more willing, because there's also another layer of risk attached to it in terms of like utilizing those assets differently than how it's always been done in the last 20 plus years. So I think we're moving toward it. So are we there yet? No. But are we making progress? Yes, we do. And can there be done more? Absolutely. And I certainly see in the conversations we have with our data center customers, there's more and more thinking along this way. How can we utilize those new on-site renewable generation assets, not only for our resiliency purpose, but also to participate with the grid and use and create financial value streams, instead of like just having a stranded asset sitting around in the electrical yard, and waiting for either being tested or waiting to be used for in case something happens to the utility grid.
Thank you very much for that. I mean, just to put some perspective on these NVIDIA H100 chips, right? So talked to a company the other day, the NVIDIA DGX architecture is being deployed in 5,000 chips per like the deployment, and that's the equivalent to about 6 megawatts worth of power. And NVIDIA, I think, is shipping 500,000 chips in the first half of the year. So that is
and they can't ship enough.
enough. So the power consumption from these guys, I would suggest, is going to be really quite, it's going to not, I mean, it's going to exacerbate the issue. Simon, let's go back to some of the stuff that Carsten was saying in terms of kind of fast frequency response and kind of the more traditional ways that you would expect a data center to integrate with the grid, coming off and going on to, backup generators. Do you do that as well? Or is that obviated by the fact that you've basically already given them a couple of 100 megawatts? So you still, but is that part of your strategy, or is that different? Do you use that strategy in other locations like London? So is your model for London different to Dublin, or you just talk about that for me?
Yeah, so I think it's location specific, right? Because what's required in Ireland isn't going to be the same as in the UK. So definitely location specific. I think what we're beginning to see a bit more of a trend towards, though, is a dumbing down of the data center. Maybe that's not the right way of putting it. A simplification of the data center itself. So we've seen a move away from centralized UPSs. We've definitely seen a move away from diesel generators. We've seen more of a focus on the networking and architecture of data center locations, as opposed to standalone assets. So I think that leads us more towards the data center being a sort of simplified and left to its own thing. So not the frequency response that maybe a UPS might have provided before. So imagine you've got a wall at that point. The flip side of that, though, is that we do have all those assets, the on-site generation, the batteries and things like that, which are still very much capable of providing those services to the grid. So that might have been a long-winded answer, but it's a way of saying, yes, we do all those things that we used to do. We probably do more of it, but we've just taken it outside of the data center and we put it into, what you might more accurately call an energy center or some sort of energy infrastructure.
Yeah, I mean, I think the part of the chat, because I think that there was a conversation in Ireland, wasn't there, about which data centers would be prepared to go on to backup generators if the grid needed it, right? And I don't think not everyone was quite as willing to as you would have hoped. And I'm assuming part of that is down to the nature of generators, because they're not designed to run 730 hours a month, are they? They're more of a standby. So if you look at your generating assets that you've got in terms of the gas assets, a couple of questions. Are they're more able to run, they're more kind of grid
sure.
based assets. Are you capturing the carbon on those? Are you, or how does that work in terms of the carbon capture for those gas generating assets?
Not in the initial deployments of these, but it is a project that we're actively looking at the moment. It's either carbon capture post combustion, or we're looking at carbon extraction pre-combustion. So essentially creating blue hydrogen. I think that's what I call it, blue hydrogen for consumption. Then it's just tricky though because of the volumes. Again, we're back to big data centers, lots of electricity requirement to sort of capture that carbon and to dispose of it or store it or sequester it. You come into you get a big difficulty. I get that the answer is not to pump it into the atmosphere, and that's why we're in the trouble that we're in. But I think that we're looking more at a medium-term ramp down of those thermal assets and a longer-term ramp up of the renewables to solve that problem, so that when we do actually go to burn fossil fuels, it'll be on an intermittent basis and only when the grid really needs them.
Yeah. So one of the questions that, in a roundabout terms, that has come from the audience was talking about the power pricing, right? And whether the electricity costs for grid power and on-site generation, how those two things are impacting. And if you look at the power prices in Europe at the moment, I would imagine that it's much more cost effective for you to build these energy generating assets now than it would have been pre the power spikes that we've experienced over the last couple of years.
I suppose again we got to be location specific. You go to Spain, you get they get a lot of their base load from renewables. You go to France, it's going to be based on nuclear. You go to Poland, it's going to be based on coal. You go to Ireland and UK at the moment, and the price is really set by gas. So once you factor that in and you factor in a return on investment for our plant, the price of electricity that would go to a data center customer versus the price that goes to a data center customer from our on-site generation ends up being roughly the same. We don't expect that to prevail into the future. We expect that gas over time to be relatively more expensive than the grid as more renewables come on. But we don't expect that within the sort of next 10 years. But to answer your question simply, in Ireland, it's roughly the same price at the moment to the end customer.
Okay.
So if you don't mind, Dan, I want to add to it. So I mean, we see that you can do sustainable on-site power generation somewhere between 10 and 15 cents a kilowatt hour, right? And that's US cents, whatever, not euro cents, but it's kind of close, right? Now, depending where you are geographically, certain regions in the United States, where you can buy power for sub 10 cents a kilowatt hour, then all of a sudden, yes, it's cheaper to buy it from the utility company. But in other markets, all of a sudden, it's more affordable to actually do it on site yourself. And yes, one of the questions earlier about the different assets, I mean, CHP or gas turbine plants, they're designed to run 24/7, right? As prime power generation assets, similar to like certain fuel cells we see, where they've been used for prime power substitution. But then there's other technologies, they're more suited towards backup generation. So not running 24/7 for an extended period of time. So it depends again where you are, what the costs are, what options you have. And for example, Simon, I guess, in order to run these gas turbines, you need to have access to gas as well, right? So at the right quantity, it's not just like me putting a gas stove in my house, and it's fine. So, but running 100 megawatt on prime power, all of a sudden it requires a different amount of BTUs, and it needs to be available. So it's not suitable everywhere, but it's certainly a great option.
So listen, my last question for you guys, and it's hopefully quite appropriate, is let's talk about software for a minute, right? We've got, I mean, Google, can tell me pretty much where anything is on the planet within seconds, right? The ability for software to do what man can't do right now with these AI models. I mean, how useful is software in kind of us reaching this utopia of kind of energy interaction with the grid? And what do you see, Carsten, from your perspective, and what are you using, Simon, from your perspective?
Yeah, so I like it what you said about let software do what humans can't do, right, with themselves. When I think of the traditional data center design, very what I call a static sequence of operation, right? Power goes out, we detect it, generator fires up, ATS switches over, and the UPS carries us over in the meantime. And then vice versa when we switch back. In this kind of grid interactive scenario where we have multiple generation assets, wind, solar, battery energy storage system, maybe some generation assets, including like gas turbines or fuel cells of some sort, So now it depends on the weather, the utility price. There's different factors that all equate to making the right decision as to when am I buying, how much am I buying, when am I charging my batteries, when am I discharging my batteries, how do I participate? So all of a sudden that transforms the usage from a static sequence of operation to more of a dynamic sequence of operation. And today's operation or sequence of operation might look different in the mornings versus the afternoon versus tomorrow. So there's a level of risk also associated. And I think if I heard you right, Simon, you use those grid participations, not necessarily in the data center, but in an energy park or whatever you mentioned it. So you de-risking your you participate, but you de-risk your operation. And I think, we all need to we all need to crawl, walk before we can run, and I think we see this shift in software. And at Schneider Electric, we do have these software applications available already, for all the different microgrids we already have installed in various applications to leverage this dynamic sequence of operation while maintaining resiliency, while becoming more sustainable, and while cost optimizing the system itself.
And
yeah, I'll probably add to that. And I'll pick up one of the questions from the group chat as well about the move to off grid or mini grid campus. We at Echelon had to move away from thinking of ourselves as data center guys in this. We did actually have to put ourselves in the shoes of the grid and what would they do. And we almost got to the point where we had to set it up as, okay, you guys look at the generation and the power side, you guys look at the data center, and we'll deconflict them until we get an answer that suits both sides, because there is quite an antagonistic relationship in there, but between protecting the grid and protecting the data center, providing uptime to the data center and not over exercising the grid. So we had to, as I said, take ourselves out of data center world and put ourselves up a level and across being a grid operator as well. That's been a challenge, technically from a software perspective, from nuts and bolts perspective, and then really very much from a people perspective as well. You're drawn from a very small pool of people that know how to do this and can execute it properly. Someone that knows the vendors and someone that knows, as you were saying, Carsten, that can move from a static DOO or SOO to a dynamic one. It hasn't been easy. I'm not sure that we figured it all out yet, but we're reasonably confident in our abilities to deliver data center uptime at this point.
Cool. Well, gentlemen, thank you very much for your time. Really enjoyed the conversation. I wish you both every success for your endeavors, and hopefully we will be able to talk again further down the line and see how things are going on. Because I think from your perspective, Simon, have you handed over your energy center yet, or are you still kind of?
No. They're still out there today plugging away. So yeah.
Yeah, so it'd be good to see what happens with that when that is handed over.
Hey, listen, no one's as excited as me. So yeah.
All right, gents. Take care, everyone. Thanks for joining. This will be available
Thank you.
online, and thanks for supporting Digital Infra Network. Thanks,
Thanks,
everyone.
everyone. Cheers.
Bye.